Okay, to solve 63, the directions say that each point lies on a parabola that has its vertex at 0, 1. The thing that you need to know about this vertex, okay, the vertex is on the y-axis, therefore the y-intercept is going to be 1. Remember, in standard form, the y-intercept is always c. So in this case, c equals 1. And there's several ways to do this, but according to what we know, I'm going to show you this particular method. Knowing that c equals 1, we still have to find a and b, so that's two unknowns. So we have to write two equations. Well, in addition to knowing the y-coordinate of the vertex, 1 being the y-intercept, we also know that the x-coordinate is 0. The formula for finding the x-coordinate of the vertex is x equals a negative b over 2a. Well, in this case, x is 0, so 0 equals a negative b over 2a. In a quadratic function, a cannot be 0 because it would no longer be quadratic. So we know that we're not going to be dividing by 0, but in order for this to equal 0, b would have to be 0. So in this case, we now know that b equals 0. So we have c equal to 1, b equal to 0. The last thing we have to do is find a. Well, we know that the standard form of a quadratic function is y equals ax squared plus bx plus c. In this case, we know that one of the y-coordinates that we have is 15 equals a. The x-coordinate is 8 plus b, which is 0, which would completely eliminate that term, plus 1. So 15 equals 64a plus 1. So when we subtract 1, 14 equals 64a. When we divide by 64, yeah, that makes sense. It should be negative 1. Sorry. So this would be negative 16. And a then reduces to negative 1/4. This should have been negative right there. So now that we have a, we have b, and we have c, quadratic function in standard form is y equals a negative 1/4 x squared plus 0x, which we're not going to write, plus 1. One other thing that would actually make this shorter is anytime that the vertex is the y-intercept, mathematically b is going to have to be 0. So in this case, we already knew b was 0. We only need one more equation to solve for a. We could have just used the standard form of the quadratic function right there. But that is the correct answer, and that's a pretty easy way of doing it.